Welcome back to All This Math. This is Professor Parker. Make sure you are subscribed to the All This Math YouTube channel. Make sure you tell people about the All This Math YouTube channel. Make sure you like this video. Make sure you share. Today's video is brought to you by the late scholar Frantz Fanon. There's a picture of him on my t-shirt. Frantz Fanon, author of Wretched of the Earth, which many members of the Black Panther Party read when they joined the Black Panther Party back in the 1960s. Also, Black Skin, White Mask. Also, Toward an African Revolution, I think was the title of another one of his books, and A Dying Colonialism, I think was the title of another one of his books. Also, many biographical texts have been written about the brother Frantz Fanon. Frantz Fanon from Martinique in the Caribbean, migrated to, went to medical school in France, then was down in Algeria and Northern Africa with the people, and then became a revolutionary. And he was a psychiatrist, went to medical school, became a psychiatrist, but studied colonialism and its effect on people of African descent. So definitely check his work out. All right, now, this problem we're about to get into is about kite geometry. Kite geometry. All right, so this is a kite. That's what a kite looks like. All right, and there's a question that we're going to answer that I did not write on the board, but you can find the question written in the notes underneath of the video. All right, so I'm going to read it out loud and read the information out loud. It says ABCD, figure ABCD. A, B, C, D. That's why it's called A, B, C, D. That's a name. Every geometric shape has a name, just like I got a name, you got a name. People have names, you know what I'm saying? Pets have names, right? Cities have names, states have names. Geometric shapes have names. This is called A, B, C, D. All right? It's a kite. Segment AC from here to here, point A to point C, is perpendicular to DB. What does perpendicular mean? That means that when those segments cross each other, they form a 90-degree angle. So from this segment from here to here, when it crosses this segment, they form a 90-degree angle. That's why this box is right here. When you see that box in the corner inside of it where an angle is, that means it's a 90-degree angle. So if you put a protractor on there, that means it is 90 degrees. That's 90 degrees. All right. Now, what else do we know? And it says that DE is equal to EB. Where's DE at? DE is from point D to point E. Where's EB at? From point E to point B. All right. So this segment is congruent to this segment. That's why these hash marks are right here. See the two hash marks and the two hash marks? In geometry, when you see that, that means that those segments or those parts or those pieces of that shape, they are congruent to each other. Or they got the same length, same distance, whatever. All right? So that's what this means, right? They usually use one hash mark. They use two for some reason. I don't know. Anyway, what else do we know? What else we know? Oh, the question. The question is, well, our instructions are to calculate the length of AC. Where's AC at? From this point to that point. This point to that point. So we got to use what we know to figure out what we don't know. So we don't know what the length of AC is right now. We can figure it out though, but we got to take some other information and figure that out, and then that'll be able to tell us. We got to, and it says to calculate the length of AC to the nearest tenth of a centimeter. So you got to make sure you got them elementary school skills and you know how to round numbers. Because if you don't round it to the nearest tenth, you round it to the nearest hundredth, thousandth, 10,000th, or to the nearest whole number, your answer's wrong. All right? You don't want a wrong answer. All right, so look. As I look at this problem, right, at first I look at this and I'm like, well, like anybody, I'm like, yo, I don't know how to do that. Like, what can I do to figure out the answer to this question? That's part of what geometry is about. Don't get all caught up in just the shapes and the angles and all that. Like, geometry is about teaching you how to solve problems, right? So if you can solve a problem in geometry class, you should be able to solve problems in everyday life, because the same thought process you got to go through to solve a problem in geometry class, figure out what information I need, figure out what information I got to use, figure out what I got to do with that information to figure out what I don't know, is the same thing you got to do in the street, the same thing you got to do on the block, the same thing you got to do when you're riding the bus, riding the train, when you're driving somewhere, when you're in the hallway in school, or wherever you at, when you're in your house and you're trying to figure some things out. Same way you got to figure out and solve problems when you're playing a game, whatever, right? The way we solve problems in geometry is the way we solve problems in everyday life. So keep that in mind. Don't get all caught up thinking, when am I going to use this stuff? Why I got to learn this? What do I need to know this for? This is teaching you how to solve problems. Responsible adults, responsible human beings, even children, need to know how to solve problems. And people that don't know how to solve problems, their problems never go away. Their problems get worse and worse because they persist and they grow exponentially. So that's another math term. We're going to talk about that in another video. But anyway, I got to sit and I got to look at this. I got to figure some things out. Now I'm trying to figure out the length from A to C. All right. But I got to look. Sometimes you got to zoom out, take a step back and say, well, what are we working with here? This is a kite. But what's this kite made of? It's made of right triangle, right triangle, right triangle, right triangle. How do I, now I know this is a right triangle because it's got a right angle, but how do I know this is a right triangle? Because this got to be a right angle also. How do I know that? Because this is a straight line. Straight lines have an angle measurement of 180. If I know that this angle is 90 and both angles got to add up to 180, what the other one got to be? The other one got to be 90. So that means this is a right angle. So if this is a right angle, this is also a right triangle. If this is 90, this is also a straight line, right? This is a straight line. The angle measurement of this line is 180. So if I put a protractor on here, whenever you measure a straight line, it has an angle measurement of 180. Because a straight line is an angle. I know that sounds crazy, but a straight line is an angle, right? It's got an angle measurement of 180. So if this right here is 90, what does this got to be? This angle got to also be 90 because 90 plus 90 equals 180. So you see what I'm saying? Like geometry teaches you how to think. You got to think and use critical thinking. Use some common sense, combine it with some critical thinking, and figure stuff out. You got to figure stuff out. Don't get caught up in, oh, I'm not gonna be out in my life like measuring triangles and all that. No, you might not be. You might not be, but you're gonna be in life needing to figure things out. And if you can't figure things out, you're gonna have some serious problems. So take advantage of the opportunity to practice thinking in geometry class. So this got to be 90, and if this is 90, this got to be 90 because that's still that same straight line. All right. So we got 4, which means we have 4 right triangles because right triangles have one 90-degree angle. This got a 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 90-degree angle. So we got 4 right triangles. Now, something else I know. I know that in this right triangle, this segment is 9 centimeters. We call that the hypotenuse. That's the name for that. The side that's across from the right angle. That's the right angle. That's the side across from it. That's called the hypotenuse. 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 Right? So we know it's 9 centimeters. We also know the length of this. It's not written, but we read the problem. The problem said that, what does it say? DE is equal to EB. Now, if the length all the way across from D to B is 10 centimeters, split them in half. That's got to be 5, and that's got to be 5. Matter of fact, let me write that. If D to B is 10 centimeters, and these are equal, cut them in half. That's got to be 5. That's got to be 5. They both 5. They both 5 centimeters. So now, in this right triangle, I know the length of this leg and the hypotenuse. What I need to know, because I'm trying to figure out what AC is, right? So ultimately, I need to figure out what this is and what this is, right? But isn't this also just a leg of this right triangle or that right triangle? Isn't this also just the leg of this right triangle, or that right triangle, or that right triangle? It is. So how can I figure out the measure of this leg of this right triangle? There's a little formula that we use that actually came from ancient Africa, ancient Kemet to be exact. But there was this Greek guy that studied over there under our ancestors for 22 years, right? His name was Pythagoras. And there's a formula called the Pythagorean theorem that's named after him. Most people call it that name, and that's fine, I guess, right? But just know where you learned it from. A squared plus B squared is equal to C squared, right? So one leg squared plus the other leg squared is equal to the hypotenuse squared. C is always representing the hypotenuse. And this triangle is the 9 centimeter part right here, right? So one leg squared plus another leg squared is equal to the hypotenuse squared. All right. So now we want to figure this out. Why do we want to figure this out? Always, whenever you're doing math, don't just be doing stuff randomly just because. Have a goal, right? Know why you're doing stuff in the math problem. I'm trying to figure this out because I'm trying to ultimately figure out what the length is from A to C. So if I can figure out what this is and then figure out what this is, I could just add the two together and that's going to be my final answer. I could just add this to this and then that's going to be my final answer. That's going to be the length of AC because AE plus EC is equal to AC. So this part plus this part equals the whole thing. But first I got to figure this out. I'm going to use this formula. Now, it's easy for me to think of that because I do this a whole lot. And I've been doing this for years. If you don't have a lot of experience with geometry, you don't have a lot of experience with A squared plus B squared equals C squared, don't feel bad. Give yourself grace. But you got to put the work in practice so that you'll get to the point where you just can recognize this stuff easily, right? What most people do is they say, oh, it's too hard. I can't do it. I don't know. How am I supposed to know to do that? You got to do problems. A lot of people are not good at math because they don't do math. Once you start doing math, you get good at math. Straight like that. It's really that simple. A lot of people are bad at math because they don't do math. How you gonna get good at something that you don't do? Basic common sense. How can you get good at something that you don't do? So anyway, some people wonder what is A and what is B. A and B are the two legs. Does it matter which is which? No. Right now, I'm gonna call A 5. So I'm gonna say 5 squared plus B squared. Why am I using B? Because I don't know what this is. B is EC or CE, whatever you want to call it, is equal to 9 squared. The hypotenuse is always C. So that's going to be 9 squared. So now I got to use algebra. Now we're about to do some algebra. But we're using order of operations first. 5 squared is not 5 times 2. It ain't 5 times 2. It's 5 times 5. An exponent tells you how many times to multiply this number, or if you have a multiplication statement where this is the factor, how many times will this number show up? If 5 shows up twice, what does that look like? 5 times 5. That's 2 5s. It's not 5 times 2. It's 5 times 5. So we got 5 times 5, which is 25, plus B squared is equal to 81, because 9 squared is 9 times 9. 9 squared is not 18. 9 squared ain't 9 times 2. All right, it's 81. So now what we do is we subtract 25 on both sides, because I'm trying to solve for B, but first I got to get B squared by itself, right? And then we'll do minus 25 over here, minus 25. Whatever I do on the left side, I got to do it on the right side. And now we're just doing algebra right now, right? In order to do geometry, you got to know algebra. So 81 take away 25, that's mental math. What's that? I'm going to do 81 take away 20. That's 61. 61 take away 5 is 55. No, it's not. I'm tweaking. It's 56. Yeah, it's 56. B squared equals 56. So B squared equals 56. 81 is 30 is 50. Yeah. B squared equals 56. So I got to solve for B. So I got to get rid of this exponent. So the exponent is 2. So the opposite of squaring something is taking the square root. So we got the square root of 56. Now, technically, we should do plus or minus, but we're dealing with an actual shape with length. So ain't no way we can have a negative, length for this leg of this triangle. So in this particular situation, we disregard the negative, right? Good vibes only, positive vibes only. In this type of problem, we only deal with the positive result. So the square root of B squared is just B. The square root of 56 is, let me check my notes. 7.48. 7.48. That's not the final answer though, right? Don't get all happy. That ain't the final answer. That's just from this point to that point. 7.48. So this is 7.48. But we need to know what the length is from this point all the way to that point. So we got to go from here to here. So now we got to use the same formula because this is a right triangle. These are right triangles also. Does it matter which one we use? No, because they're identical triangles. They got the same measurements. That's part of also understanding the characteristics of a kite, right? That's why you got to study those things. You got to study the definitions in geometry. You got to study the characteristics and the attributes of the different shapes. You got to study. You got to read. You got to do the work. All right, so now I want to know what this leg is. I need to know what this leg is. So I'm using the same formula because it's a right triangle, and I'm trying to find a missing leg. Basically, what I'm trying to say is, if you're doing work with a right triangle and you're trying to find the length of a missing leg, you're probably using the so-called Pythagorean theorem. Notice I said so-called. I already explained that a little earlier in the video. But anyway, A squared plus B squared equals C squared. So A is one of your legs, which is 5, just like it was in this part up here. So that's not a 52. That's 5 squared. All right, that's not a 52. That's 5 squared. And then B we don't know. Yeah, B is right here. Yeah, B we don't know. So B squared is equal to C squared. C is the hypotenuse. That's this right here. That's 8. That's that 8 right there. So we got 8 squared. What's 5 squared? It's not 10. It's not 10. It's 5 times 5. 5 squared is 5 times 5, which is 25. So we got 25 plus B squared, and then 8 squared is not 16. 8 squared is 64, because it's 8 times 8. That's 64. So then we got B squared is equal to, subtract 25, subtract 25. Just like we subtracted 25 and subtracted 25. To isolate B squared, we got to get rid of the 25. So we do the opposite of having a positive 25. The opposite is subtracting 25. I know I'm talking fast, but that's what you can pause and rewind for. Run it back. Run it back if you need to. All right, 64 minus 25. Do the mental math. 64 minus 20 is 44. 44 minus 5 is 39. B squared is equal to 39. But that's not what B is. We're looking for B. So in order to know that, you take the square root of B squared and you take the square root of 39, it should be positive or negative, but we're not dealing with the negatives because we're dealing with an actual length right here, and we can't have a negative length in a kite or in an actual shape. So b squared is equal to 39. Let's go up here with it. B equals the square root of 39. Throw that in your calculator, you get 6.24. 6.24. We almost done. We're almost done because this is 6.24 now. 6.24, 7.48. So now AC is the length from this point to that point to that point. Well, this point all the way to that point. So we're doing 6.24 plus 7.48. 6.24 plus 7.48. 6.24 plus 7.48 is equal to AC. So add them up. 6.24 plus 7.48. I'm stepping over here to look at my notes. If you're wondering why I'm not in the camera. That's like 13.7 centimeters is equal to AC. Boom. That's the final answer. Yeah. I know that's a lot, or it seemed like a lot. This video took like 16 minutes. But I be talking a lot, doing ad libs and trying to be a math motivational speaker and all that too. So if I'd have just ran through straight, just did the problem, we'd have been done in like 2 minutes. But that's not good teaching. That's not good teaching. That's what a lot of college professors do sometimes that don't know how to teach. Unfortunately, you gotta know how to explain stuff, how to break stuff down. You gotta know how to zero in on the parts where a lot of students are probably gonna make a mistake, right? You gotta know how to focus in on that. All right. And you gotta provide that motivation. You got to talk about math. All right, we gotta have different conversations about math because a lot of people are scared of math and they shouldn't be, but you gotta have the conversations to counter a lot of the conversations that they've heard throughout their life already. But anyway, final answer 13.7 centimeters from point A to point C. This is 6.24 centimeters. This is 7.48 centimeters. So that's what we're working with. That's what we're working with. All right, but notice what we had to do. We had to first recognize that this was a right triangle, this was a right triangle, this was a right triangle, this was a right triangle. We had to use what we had to get what we want. Use what you got to get what you want. We had to use the Pythagorean theorem, so-called Pythagorean theorem, right? We knew one of the legs, we knew the hypotenuse. We used that to figure out the missing leg, right? And then we used it down here in this right triangle also to figure out the missing leg. And then we just add the missing legs together. So geometry is a lot about logic. It's a lot about critical thinking. It's a lot about using common sense, right? To figure out solutions to problems. We need to learn math so we can be able to solve problems. If you don't know math, or if you don't practice math, I should say, you're robbing yourself of the opportunity to learn how to solve problems. And you want to be a person that knows how to solve problems. All right. So it's enough of that. Practice, 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 and learn about France for Fanon. Study France for Fanon. All right. Peace. See you on the next video.